Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang.
Hello and welcome to my video about the theory of parallel universes. In this video, I will help you to understand about the theory with a thought experiment. But first, a little history about the founding of the theory. In 1954, a young Princeton doctoral candidate named Hugh Everett III came up with a radical idea that there existed parallel universes exactly like our own. These universes are all related to ours. They all branch off from ours, and our universe is branched off from others. In these parallel universes, our wars would have had a different outcome. Species that we know to be extinct could have evolved and adapted in these other universes. In these other universes, we as humans may have become extinct. How scary would that be? To know that somewhere out there, we would not be leaders of an Earth-like planet. According to Niels Bohr, a Danish physicist, when we observe a quantum object, we affect its behavior. Observation breaks an object's superposition and essentially forces the object to choose a different wave function. For example, say an object's wave function is both a particle and a wave. When the physicist measures the particle, there are two possible outcomes. It will be either measured as a wave or a particle. The physicist measures the object. The universe splits into two distinct sections to accommodate each outcome. So if a scientist in one universe measures the wave function in the form of a wave, that same scientist in another universe could measure the wave function in a particle form. This also explains how a particle can be measured in more than one state. So the main question is, do parallel universes really exist? Well, according to the many worlds theory or the parallel universe theory, we can't really truly be certain since we cannot be aware of these other parallel universes. So a thought experiment can be done to help us understand how this theory works. This thought experiment is called quantum suicide. This idea was first posed by a Princeton University theorist named Max Tegmark in 1997. In this thought experiment, a man sits down before a gun, which is pointed at his head. This is no ordinary gun. It's rigged up to a machine that measures the spin of the quantum particle. Each time the trigger is pulled, the spin of the quantum particle is measured. Depending on the measurement, the gun will either fire or it won't. If the quantum particle is measured as spinning in a clockwise motion, the gun will fire. If the quantum particle is spinning in a counterclockwise motion, the gun won't go off. There'll be only a click. Nervously, the man takes a breath and pulls the trigger. The gun clicks. He pulls the trigger again. Click. And then again, it clicks. The man will continue to pull the trigger again and again with the same result. The gun won't fire. This gun is working correctly with loaded bullets, but no matter how many times he pulls the trigger, the gun will never fire. So he will be there for an eternity without dying, therefore becoming immortal. Okay, let's suppose we go back in time to the beginning of the experiment. The man pulls the trigger for the very first time, and the quantum particle is now measured as spinning clockwise. The gun fires and he is dead. But wait! The man already pulled the trigger for the first time, and an infinite amount of times followed that. And we already know the gun didn't fire. How can the man be dead? The man is unaware, but he is both dead and alive. Each time he pulls the trigger, the universe is split into two. It will continue to split again and again each time the trigger is pulled, thus creating an infinite amount of universes. So you see, the parallel universe theory could actually be true. But it would really be impressive to see a real live experiment done to prove this theory. Well, it looks like that's all the time we have for today. Thank you for watching my video, and I hope you learned something new today.